On November 15th, a day that would later be marked in history, the physicist Michio Kaku stepped before the world's cameras and made an announcement that altered the course of human thought. He spoke of an unprecedented scientific discovery, a finding so profound it seemed to belong to the realm of fiction. The subject was an interstellar object, a traveller from the void between stars, designated 3I Atlas. Citing a wealth of data meticulously gathered by the James Webb Space Telescope, Kaku delivered the core of the revelation. There was compelling evidence to suggest that within Atlas, or perhaps as an integral part of its very structure, there existed complex biological activity. This was not a vague hint or a speculative theory. It was a conclusion drawn from a cascade of interlocking and deeply strange observations. The evidence he presented was staggering in its scope and its implications. Scientists had detected strange organic molecules, complex chains of carbon that had no business forming in the cold, dead vacuum of space. They had found anomalous isotopic ratios, chemical fingerprints that did not match anything in our solar system, suggesting an origin story far older and more exotic than our own. There were unexplained thermal irregularities, pockets of heat that pulsed with a strange rhythm, defying the simple physics of a frozen rock warming in the sun. Perhaps most tellingly, there were remarkable chiral properties, a specific handedness to its molecules that is considered a hallmark of life, and even direct evidence of bioluminescence, a cold, rhythmic glow that pulsed from the object's dark side. I want to be clear about what this meant. Taken individually, any one of these signs would have been a major discovery, but together they formed a mosaic of evidence that was impossible to ignore. As Kaku stated with a gravity that silenced the room, these signs, in their totality, defied any and all explanation by known abiotic natural processes. They pointed towards something organised, something complex, something that was, for lack of a better word, alive. And then came the final, alarming piece of the puzzle. The object, 3I Atlas, was not behaving like a simple wanderer. It appeared to have altered its trajectory, a subtle but deliberate change that would keep it from flying back out into the interstellar dark. It had chosen to remain within our solar system. More than that, the object was now on a slow, calculated approach path toward Earth, raising the most urgent questions humanity has ever faced about intent, about our place in the cosmos, and about how we should, or even could, respond. The story of 3I Atlas began not with a world-shaking announcement, but with a quiet, methodical observation. The James Webb Space Telescope, our most powerful eye on the universe, turned its golden gaze toward a previously unmapped interstellar object. At that very moment, as the first photons from this distant traveller struck its sensors, the journey into the unknown began. The initial task was simple reconnaissance, using the telescope's sophisticated instruments, the near-infrared spectrograph, or NIRSpec, and the mid-infrared instrument, known as MIRI, to get a basic profile of this celestial guest. What came back was anything but basic. The very first images revealed a highly reflective structure that immediately defied all baseline expectations for cometary dust. It was too bright, too sharp. Normally, a long-period comet, a dirty snowball from the outer reaches of the solar system, develops a fuzzy halo as it nears the sun. This halo, called a coma, is formed by ice and dust sublimating, turning directly from solid to gas and diffusing into space. But Atlas showed minimal coma diffusion. It was clean, its edges crisp against the black of space. Instead of a vague cloud, it emitted a tightly columnated spectral line, a focused beam of light that indicated a surface composition that was not just unusual, but highly ordered. It was the first sign that this was no ordinary rock. The NIRSpec instrument then provided a closer look, corroborating the spectral anomaly with a series of high-resolution snapshots. What these images revealed was breathtaking. Shimmering in the ultraviolet scatter from our sun was a distinct hexagonal surface pattern, a geometric tiling that covered large portions of the object. These were not the random, chaotic reflections you would expect from a fractured, cratered surface. The geometric symmetry was too precise, too perfect to be accidental. As Atlas slowly rotated on its axis, the angles of these reflections changed in perfect alignment with the light vector from the sun, a subtle but unmistakable sign of a structured non-random surface. For 11 long days, the JWST maintained a continuous, unbroken watch, its instruments locked onto this enigmatic object. The observation campaign quickly expanded. Auxiliary optical arrays from the Subaru telescope, perched high on a mountain in Hawaii, and the European Space Agency's Gaia Observatory, orbiting 1 million miles from Earth, joined in a synchronized lockstep. This international coordination was not merely procedural. It was not a routine sharing of data. It was a direct and urgent response to a growing sense of scientific unease that was rippling through the astronomical community. The feeling was palpable, a quiet whisper in the control rooms and data centers around the world. This object wasn't just drifting, it was behaving. That single, unnerving word, behaving, was the spark that ignited a firestorm of activity. It prompted a cross-consortium emergency session within the Planetary Defense Coordination Office, the PDCO, the very body tasked with protecting Earth from cosmic impacts. Suddenly, this was no longer a matter of pure scientific curiosity. It was a matter of planetary security. A decision was made to initiate real-time data mirroring between all participating agencies. Every byte of information, every photon captured from Atlas, would be shared instantly across a secure global network. No single nation or agency would hold the keys to this mystery alone. It was during this period of intense scrutiny that researchers at the renowned Max Planck Institute in Germany made a pivotal observation. They were analysing the light curve of 3i Atlas, which is essentially a graph of its brightness over time. They noted that its brightness varied, but not in a way that correlated with the turbulence of the solar wind, the stream of charged particles flowing from the Sun. Instead, its light curve varied in direct response to the solar angle, the precise direction from which the sunlight was hitting it. The implication was profound. It suggested a process of reflectivity optimization. In effect, Atlas seemed to be actively modulating its signature, perhaps making itself brighter or dimmer in a controlled fashion. Let's pause on that for a moment. This was no longer just observation. This was interaction. A passive object, a dead rock, simply reflects light according to its composition and shape. It doesn't adapt. It doesn't respond. But Atlas did. In the silent, unforgiving vacuum of space, it was adapting, intelligently or otherwise, to its environment. The sense of unease solidified into a quiet, focused alarm. By the 12th day of the observation campaign, 3i Atlas reached a critical point in its journey. It entered its first perihelion window, the point in its orbit where it is closest to the Sun. For a period of 73 hours, it would slip behind the solar curtain, completely hidden from our view by the blinding glare of our own star. And for those 73 agonizing hours, the Earth lost sight of it. We lost sight not of a simple rock, but of something far more deliberate, an entity that had already demonstrated that it was anything but predictable. When the solar occultation finally ended, and the full silhouette of 3i Atlas returned to the awaiting senses of our telescopes, a new and even more bewildering layer of complexity emerged. The data that streamed back to Earth revealed a surface that challenged every natural model previously used to classify interstellar bodies. It was as if the object that went behind the Sun was not the same one that came out the other side. The first and most striking discovery came from the thermal maps. These maps, which show the distribution of heat across a surface, revealed that Atlas was not uniformly cold, nor was it heated in a predictable way by the Sun. Instead, it carried a network of localized hotspots, specific points of elevated temperature arranged with a precision that mirrored engineered layouts, rather than random geological placement. These hotspots were not just randomly scattered. Each point maintained a consistent angular spacing relative to the sunlight hitting the object. Even as Atlas continued its journey, shifting from a hyperbolic trajectory, a one-way trip through the system, to a new elliptical orbit, this precise pattern held firm. It was a geometric arrangement that defied any known natural heating or cooling process. When the science teams compiled the heat distribution data over time, the pattern behaved less like cooling mineral strata on a rock, and more like a controlled dynamic system. Heat appeared to rise and disperse in rhythmic, predictable intervals, a cycle that suggested a circulatory or perhaps even a metabolic process was happening just beneath the visible crust. Further analysis only deepened the puzzle. These distinct heat signatures were not isolated islands of warmth. They were connected by branching corridors of elevated temperature, faint lines of heat that linked the hotspots together. The topology of this network was eerily reminiscent of vascular pathways in a living organism or the distributed neural filaments of a complex network. It was a pattern recognizable in biological systems, not in inert, cold rock. This was the first hint of something truly organized, a system designed to manage and distribute energy across its entire structure. It was a vascular network, a circulatory system made of heat, pulsing just below the surface of this visitor from the stars. At the same time, the spectroscopic data began to reveal even more anomalies. Irregular carbon chains were detected across the reflective panels of Atlas, complex molecular structures that were not supposed to be there. But the most shocking discovery was their biased chirality, a specific molecular handedness that indicated a process of selective synthesis rather than the random chemical drift you would find in nature. This reinforced the growing suspicion that these compounds did not arise by chance, but were created through regulated chemical pathways, much like the processes inside a living cell. The consistency of these interlocking anomalies began to fundamentally shift the interpretation of what 3I Atlas was. The idea of a silent cometary remnant was discarded. In its place, a new image began to form, that of an integrated system, an entity that was responding dynamically to its environment, adjusting its thermal output with the precision of a finely tuned feedback loop. Researchers who were observing the long-duration scans of the object noted a cyclical emission spike, a brief pulse of energy that occurred every 243 to 248 seconds. The timing was incredibly stable, a narrow range far too consistent to be attributed to simple solar heating or random outgassing. In their internal reports, the language began to change. Scientists, who are by nature cautious and skeptical, started referring to these regular pulses as functional signals rather than incidental noise. The deeper the scientific community looked, the more Atlas resisted any easy categorization. It presented a suite of signatures that all converged on a single, startling implication: coordinated behavior. For the first time in the history of astronomy, an object was being evaluated not as a wandering mass of interstellar debris, but as a structured entity, an entity that carried within its very geometry the clear indicators of organization, optimization, and possibly, just possibly, agency. This investigation was now pushing into uncharted territory, a place where biology, physics, and the great unknown met without any clear boundary. What had begun as a routine observation of a distant object had become a profound and unsettling encounter. In the days that followed its dramatic passage around the Sun, as 3I Atlas moved beyond the heliopore's interaction zone, it began to display a set of behavioral anomalies that could not be attributed to the simple, predictable physics of an inert celestial body. The object's surface temperature, which should have been cooling steadily as it moved away from the Sun, began oscillating in tight synchronization with the local solar flux. This wasn't a gradual passive response like ice slowly melting and refreezing. Instead, the temperature changes occurred in sharp feedback curves that mimicked an anticipatory adjustment. It was almost as if Atlas was predicting its solar input in advance and preemptively calibrating its surface albedo, its reflectivity, to manage the energy load. At first, many researchers suspected this was a simple phase delay artifact, a glitch caused by a lag in the sensor relays between the telescopes and the data centers on Earth. It was a logical, conservative explanation, but as observations accumulated across the entire electromagnetic spectrum, from X-ray and ultraviolet to thermal infrared, the timing precision held. The adjustments were confirmed to within milliseconds across multiple, independent observation platforms. The conclusion became inescapable. Atlas was not reacting passively to the Sun's energy. It was engaging in an active, sophisticated strategy of thermoregulation. It was managing its own internal temperature with a level of control that was simply baffling. A particularly dramatic event provided even more evidence of this active system. As a sudden burst of solar wind, a powerful stream of charged particles from the Sun intensified near its perihelion, the outer layer of Atlas emitted a sudden plume of molecular hydrogen and carbon radicals. But this was not a simple, uniform outgassing event. The plume was emitted only from the hemisphere of the object that was facing away from the solar direction. The implication of this was staggering. It suggested a directional shielding mechanism, a system that could selectively release mass from a specific location to maintain torque balance and avoid the destabilizing momentum that such an event would otherwise cause. It was actively counteracting the push from the solar wind. Furthermore, this ejector did not disperse into space following the normal ballistic patterns of gas and dust. It didn't spread out randomly like smoke from a fire. Instead, the material formed a controlled, coherent arc, curving away from the expected gravitational vectors and trailing for kilometers behind Atlas in a stable, cohesive plasma strand. This was a clear sign that Atlas was not just shedding mass as a defensive measure, it was shaping its wake, controlling the plasma it released with a precision that defied our understanding of natural processes. It was another layer of control, another piece of the puzzle that pointed away from nature and toward design. Over the next 48 hours, Earth-based observatories that were tracking the polarization angles of the light reflected from Atlas reported yet another series of strange shifts. Its surface darkened by a remarkable 18% while it was under the increased photonic pressure from the Sun, and then, just as mysteriously, it brightened again after it had cleared the solar ecliptic. These dramatic changes in reflectivity could not be explained by dust coma fluctuations or by the object's rotation alone. They strongly suggested an active modulation of its surface materials, possibly by reorienting reflective compounds or altering dielectric structures to counteract the immense radiation load. It was as if the object had a skin that could change its properties on command. Biologists who were part of the interdisciplinary task force began to raise a fascinating possibility. They suggested that Atlas was demonstrating something akin to adaptive camouflage, though not for the purpose of concealment, but for survivability in a hostile environment. A new working term, the adaptive index, was coined to measure the object's response latency, its efficiency, and the inverse entropy effect it had relative to the solar radiation it encountered. On this new scale, 3i Atlas scored an astonishing 0.87, a value far higher than any non-biological system ever recorded. It was adapting to its environment with an efficiency that bordered on biological. Meanwhile, the object's orientation, its physical attitude in space, began to subtly shift. It was not tumbling chaotically, as would be natural for an object experiencing irregular jetting and outgassing. The changes were micro-adjustments, tiny corrections that suggested a sophisticated system of torque vector control. Over the course of 6 days, its rotational axis aligned itself increasingly with its flight vector, a behavior consistent with an object trying to minimize drag or perhaps preparing for a future maneuver. When the science teams ran their simulations backward, they made another startling discovery. This alignment process had actually begun hours before. The first solar ejection was observed, once again pointing to a pattern of preemptive anticipatory behavior. If 3i Atlas was indeed anticipating solar events, then it had to be mapping space-time conditions in real time and acting on that information. The possibility emerged that the object housed a complex internal system, whether it was mechanical, energetic, or something entirely unknown, that responded to environmental variables not as a simple byproduct of its composition, but as part of its fundamental operating design. Some scientists speculated that it was a shell made of smart materials with memory properties. Others argued for a nested thermodynamic core capable of processing external inputs and making decisions. Regardless of the specific mechanism, one thing was becoming undeniably clear. Atlas was passing the established thresholds of passive interstellar drift and entering a completely new category of celestial object. It was an object where survival in transit was governed not by luck or chance, but by rule-based adaptation. For the first time in decades of cometary observation, scientists were forced to write new taxonomies, new classification systems, to try and make sense of what they were seeing. It was not a comet, not a probe, and not a relic. Atlas was now being officially catalogued as a reactive entity with behavioral indicators, a reclassification reserved only for candidates that exhibit a targeted, intelligent-like response to astrophysical stress. That new designation carried immense weight, not just among the planetary defense agencies who were watching with growing concern, but also among those tasked with assessing the profound implications of encountering an engineered intention-bearing structure from another star system. What had begun as a simple anomaly had now become a detailed profile. What had at first looked like chance now closely resembled protocol, the deep silence of 3i Atlas, far from being a sign of emptiness, had transformed into something else entirely. It was something responsive, something precise, and something that, if not conscious, was at the very least acutely aware of the space through which it passed. As 3i Atlas emerged from its first perihelion window, the intense period of its closest approach to the Sun, researchers across a global network of observatories prepared for a second wave of data acquisition. This time, the focus shifted from its trajectory and thermal properties to a deep analysis of its spectroscopic and molecular composition. With telescopes realigned and the powerful infrared arrays of the Infrared Telescope Facility, or IRTF, in Hawaii, and the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile, reactivated, a barrage of high-resolution scans was launched within a tight 17-hour observational corridor. What they retrieved from the void was utterly confounding. The outer shell of 3i Atlas was not reflecting the signatures of volatile sublimation or standard carbonaceous dust, the typical materials found on comets and asteroids. Instead, it bore distinct absorption lines, dark bands in the spectrum of light, that were consistent with the presence of complex hydrocarbons. These were not the simple, random molecular fragments you would expect to find in interstellar debris. The data revealed long-chain sequences, including complex molecules known as alkenes, and even traces of amino precursors. Most notably, the instruments detected alanine and glycolaldehyde, compounds that are heavily associated with the prebiotic chemistry that is thought to be the foundation of life. The presence of these readings alone was exceptionally rare, but what truly startled the chemical analysis teams was their coherence. These complex organic compounds were not diffusely scattered across a coma or trailing behind the object in a dusty tail. They were localized to specific structured points on the surface of Atlas. These points formed regular emission intervals that seemed to correspond perfectly with the object's rotation pattern. As Atlas turned in space, these molecular emissions pulsed in a consistent rhythmic cadence, almost like a form of biological respiration or a deliberate energy cycling process. It was a chemical heartbeat pulsing in time with its spin. The Virasi-Rubin Observatory, using its rapid imaging spectroscopy mode, added another piece to the puzzle. It picked up a distinct spectral flickering at intervals of 247 seconds, a timing that perfectly aligned with the thermal shifts that had been observed in the hemispheres of Atlas that were facing away from the Sun. This modulation pattern did not match any known cometary outgassing behavior. On the contrary, it closely resembled a system of active thermal regulation, where chemical processes were being used to manage the object's internal temperature. It was yet another sign of a complex coordinated system at work. More anomalies quickly followed. A completely unexpected spike in the presence of trace phosphorus was detected, at concentrations far beyond the background levels found in the cosmos. Phosphorus, while not unheard of in cosmic bodies, rarely occurs in the free-flowing molecular clouds between stars. On Atlas, however, it appeared to be clustered in recurring hexagonal emission blooms, geometric patterns of release that perfectly matched the hexagonal tiling that the JWST had observed on its surface earlier. This elemental clustering triggered an intense and fascinating debate among the biochemists on the team. Some argued that it might be evidence of a primitive scaffolding system, something akin to the protein folding zones that are simulated in models of early ribosomal activity. They saw it as a potential sign of a biological or pre-biological structure. Others remained deeply skeptical, citing the inherent risk of anthropomorphizing random mineral patterns, of seeing intention where there was only chaos. But as Atlas continued to pulse with its rhythmic molecular signature, those doubts began to erode under the sheer weight of the evidence. The patterns were too consistent, too structured to be easily dismissed as random chance. One of the most controversial signals came from a sharp burst of methane and nitrogen that was captured by the European Extremely Large Telescope. Instead of degrading randomly into space as a simple gas cloud would, the burst split into two distinct dual lobes that mirrored each other on opposite axes of the object. This mirrored flow resembled a form of bilateral chemical processing, which is a hallmark of adaptive self-regulating systems, and potentially even a sign of a metabolic process. The object that was once thought to be an inert piece of rock was now emitting clear signs not just of complexity, but of systemic control over its own chemistry. As the torrent of data poured into the central analysis nodes at NASA's astrobiology program and the European Space Agency's ExoLife Watch network, a question began to surface, not just in the pages of scientific journals, but within classified panels and high-level briefings. Were these strange rhythmic emissions purely accidental, a freak of nature? Or was 3I Atlas, in its own unique way, signalling? The term biosignature was initially banned from all internal memos, deemed far too speculative and too inflammatory for official use. But the pattern continued, undeniable and persistent. Spectral echoes from the emissions of Atlas began to show a periodic modulation at incredibly short 29.3-second micropulses. These pulses fell within the radio frequency harmonics that are used in advanced adaptive scanning systems on Earth. The pulses repeated in a clear sequence, then paused, and then began again, but offset by a tiny fraction of a second as the object crossed its nodal tilt. This was not noise. It was either a message, a mimicry of a message, or something that operated on principles that were both alien and strangely familiar. The larger scientific community did not reach a consensus, but a splinter group within the Lunar and Planetary Institute drafted a bold internal hypothesis. They proposed that 3I Atlas was a modular organic matrix, a structure capable of adaptive chemical feedback. It was possibly seeded with the building blocks of life, possibly reactive to its environment in a way we did not yet understand, but it was unmistakably organized. 3I Atlas no longer stood as a passive body drifting aimlessly through space. It was behaving like a coherent, iterative system, subtly and perhaps profoundly aware of its stellar context. What it was adapting to remained uncertain, but the data made one thing terrifyingly clear. 3I Atlas was not alone in its own evolution, and now Earth was a part of its biochemical equation. As the deep molecular composition of 3I Atlas continued to baffle and astound analysts, a new and even more profound layer of complexity began to emerge. This time, the mystery came from its inherent spatial symmetry, or more accurately, its very specific and structured asymmetry. Spectroscopic analysis from the European Southern Observatory's Very Large Telescope and the James Clerk Maxwell Observatory converged on a startling and almost unbelievable discovery. The light that was being reflected from specific emission arcs on the surface of Atlas was not just polarized. It displayed a distinct chiral rotation. At first, these measurements were dismissed as simple sensor noise or an instrumental artifact. Chiral polarization, also known as optical activity, is a trait that is usually reserved for complex biological molecules. It refers to the existence of left-handed and right-handed configurations, mirror images of each other, that twist light in distinct and measurable directions. It's a property that, on Earth, is almost exclusively associated with the chemistry of life. But follow-up analysis from multiple independent instruments confirmed it. The usomeric shift was real, it was stable, and it was repeated across multiple observation windows. 3I Atlas was producing and emitting optically active compounds. What was even more unsettling than the presence of chirality itself was the profound imbalance in the molecules. Instead of a random 50-50 mixture of left-handed or L-form and right-handed or D-form molecules, which is typical of abiotic chemistry, Atlas exhibited a strong and undeniable bias toward one enantiomer. The L-form amino precursors, in particular, dominated the sample by a staggering margin of nearly 94%. This percentage was eerily and uncomfortably reminiscent of the homochirality found in all Earth-based life systems, where life has almost exclusively chosen left-handed amino acids and right-handed sugars. It was a chemical signature that screamed biology. The molecular clusters that were emitting these highly specific chiral signals were not isotropic. They were not scattered randomly across the surface. Instead, they lined up perfectly along the hexagonal fault lines that had been observed on Atlas's surface, forming mirror-split crescents that rotated in counterphase across its equator. Each wave of polarized emission that came from the object traced a complex pattern in space, almost as if 3I Atlas was projecting a sophisticated spatial code out into the void. It was a signal written in the language of molecular geometry. From a purely physical perspective, symmetry in inert celestial bodies is expected. But 3I Atlas defied that fundamental norm. Its asymmetry was neither random nor chaotic. It was structured, it was persistent, and it was reactive to the shifts in the solar vector. As the object tilted along its orbital plane, the chirality of the molecules it emitted oscillated in a predictable way, suggesting the presence of some kind of internal compensatory system. It was a feedback loop between the surface chemistry of the object and the incident radiation from the Sun. The implication of this discovery sent shockwaves through the theoretical biochemistry teams that were analysing the data. The existence of such a strong chiral dominance in a non-Earth, non-solar system object demanded an explanation that went far beyond our current understanding of cosmic chemistry. Was this the unique fingerprint of a process of selective synthesis, an alien form of manufacturing? Or was it the fossil residue of a long-dead metabolic system, the ghost of an ancient biology? Either way, 3I Atlas now bore another fundamental trait that was once thought to belong solely to life: molecular handedness with a clear and undeniable intention. It was handing us a puzzle that spanned the physics of light, the deep principles of symmetry, and something far deeper, perhaps even something that was designed. The object known as 3I Atlas exhibited far more than just molecular peculiarity. It was also radiating heat in rhythmic pulses that simply did not align with any known solar heating profiles. While most celestial objects, like asteroids and comets, absorb and reflect thermal energy in predictable gradients, the emission spikes from Atlas followed a strange and consistent rhythm. It was as if its surface was responding to the solar flux not in a passive way, but with a calculated, active modulation. The thermal mapping data from both the James Webb Space Telescope and the ALMA array revealed a segmented latticework of heat patterns along the subsolar ridge of Atlas. These segments displayed alternating bands of high and low thermal inertia, arranged in a precise hexagonal grid-like formation that mirrored the physical patterns on its surface. Even stranger, this thermal network was not static. It evolved over time. It was not just warming and cooling in a simple cycle. The hot zones were observed to migrate longitudinally across the surface as Atlas approached its perihelion, suggesting a distributed energy regulating system was at work. Unlike the surfaces of typical comets, which either retain heat or radiate it erratically as they tumble through space, Atlas appeared to be actively channeling energy along discrete, well-defined pathways. These thermal veins followed non-random topologies, concentrating the heat dissipation near what appeared to be polar vents, which coincided perfectly with the locations of the jets of molecular vapor that had been observed earlier. That remarkable coordination between the thermal patterns and the molecular emissions raised a critical and profound question. Was this complex behavior simply emergent, a result of a highly unusual but still natural set of physical properties, or was it engineered? One particular hypothesis began to gain significant traction among the weary but fascinated science teams. It was the idea that Atlas was, in a functional sense, mimicking a nervous system at a massive scale. Each thermal node seemed to respond to the solar input with a delayed but purposeful shift, much like the process of bio-inspired thermoregulation seen in advanced engineering concepts on Earth. The way that heat was not merely absorbed but actively routed through this network strongly suggested a feedback mechanism, a system akin to thermal homeostasis, the process by which living organisms maintain a stable internal temperature. Adding even more weight to this hypothesis was the presence of what appeared to be phase-shifting compounds in the object's plume. These were not simple ices. Some of the crystalline forms that were detected in the material ejected by Atlas exhibited reversible phase transitions at a temperature near 120 Kelvin. This was a temperature range that seemed perfectly tailored to the specific orbital environment of Atlas. These materials were acting as highly efficient thermal buffers, absorbing excess energy from the Sun and then releasing it gradually over time, as if to dampen the internal stress on the object's structure. Researchers began referring to this system as a bioanalogous thermal net. It was not alive in the biological sense that we understand, but it behaved like something that had learned how to survive in the harshness of space. More than just simple insulation, this system seemed designed to maintain a state of chemical viability under the extreme conditions of deep space. The perfect synchronization between the thermal rhythms and the molecular ejections hinted at a master process, a central control system, whether it was one of natural complexity or of artificial design. The conclusion was becoming more and more difficult to avoid. 3I Atlas was not just reacting to the Sun, it was actively managing itself against the Sun's immense power, and somewhere within its shifting, pulsing heat map lay a design that was blurring the line between a natural comet and an artificial construct, between a rock and a machine. Among the many deep and complex scientific puzzles that 3i Atlas presented to the world, one particular anomaly stood out with a quiet but profound defiance. It was the mystery of its isotopic ratios. A detailed spectrometric breakdown of the light and materials coming from the object, conducted by both Earth-based and orbital instruments, revealed a ratio of nitrogen-15 to nitrogen-14 isotopes that deviated significantly from the established norms of our solar system. This was more than just a statistical outlier. This specific isotopic skew mirrored the distributions that had previously only been theorized to exist in the prebiotic zones of interstellar molecular clouds. These are the cold, dark regions between stars where the complex organic synthesis that could lead to life is possible, but where life itself is not yet assured. A further deep analysis of the carbon isotopes within Atlas only compounded the enigma. The presence of carbon-13 was not only elevated far beyond normal levels, but it also formed consistent localized clusters around the molecular structures that were associated with amino acids and formaldehyde derivatives. These were not the random fragments of chaotic chemistry. The isotopes were structured, they were bounded, and they echoed the patterns seen in certain meteorites that are considered to hold the fossilized remnants of ancient, pre-solar biotic material. It was a chemical fingerprint that pointed to an origin of immense age and complexity. The oxygen isotope profile was even more provocative. It did not reflect the natural process of fractionation that would occur during the formation of a solar system like our own. Instead, it suggested that the materials within Atlas had been exposed to heavy, UV-driven photochemistry in an environment that was far older and far colder than even the distant Oort cloud that surrounds our Sun. These isotopic ratios were not just chemically distinct from our own, they were narratively charged. They whispered of processes that predated the formation of our solar system, and possibly even processes that were guided by a form of selective chemical evolution. If these molecules had indeed formed in a celestial cradle far beyond our own planetary nursery, then 3i Atlas was not just a visitor from another star. It was a traveller from another, and perhaps much older evolutionary arc. A faint but persistent question began to emerge in the background of the endless streams of data. Were we staring at a molecular fossil? Was this a relic of a form of life, or pre-life, that had been crafted, selected and preserved, travelling across the vast emptiness between star systems not by chance, but by function? And if that was the case, was Atlas itself the message, or was it merely the messenger? As 3i Atlas pierced deeper into the inner solar system, its spectral fingerprint, the unique signature of light it emitted and reflected, began to shift in unexpected ways. A series of observations in the ultraviolet and visible bands of the spectrum, captured by the unparalleled sensitivity of the James Webb Space Telescope, revealed a series of emission spikes that did not correspond to any known atomic transitions. These were not the predictable patterns of light emitted by superheated elements. They were not solar reflections, nor were they the simple thermal echoes of a cooling rock. These were active emissions, pulsing at semi-regular intervals, suggesting a mechanism of energy release that was embedded deep within the core composition of Atlas. The most startling discovery of all came when these strange emissions were found to align with specific wavelength bands that are often associated with bioluminescent processes here on Earth. They were particularly similar to the light produced by marine organisms that use complex luciferin-luciferase reactions to create a cold chemical light. But in the case of Atlas, this eerie glow did not come from any detectable thermal source or any known exothermic reaction. It emerged from the cold zones of the object, far from the sun-facing hemisphere, in the deep frigid shadows of its dark side. A deep spectral deconvolution, a process of breaking down the light into its constituent parts, pointed to the presence of unidentified polycyclic compounds. These were large ringed molecules with extended pi electron systems, some of which bore a striking resemblance to the porphyrin structures that are involved in biological light emission on our own planet. These compounds were remarkably stable, they were non-volatile, and they seemed to be activated only under specific flux densities of solar radiation. This suggested some form of light-triggered photoluminescence, a system designed to absorb energy and then re-emit it as a controlled glow. What raised the level of intrigue even further was the remarkable consistency of this glow. It did not fade as Atlas moved farther from the Sun, nor did it fluctuate chaotically with the solar wind. Instead, it pulsed in perfect time with the object's rotation, like a signal that had been encoded into the body's own spin. These rhythmic pulses of light traced a path across its dark surface, like a heartbeat made of photons. In the quiet control rooms and late-night analysis sessions, some observers dared to ask the question that was on everyone's mind. Was this a biological remnant, the last echo of a living system? Or was it an engineered luminescent system, a set of beacons meant to signal, or perhaps even to navigate through the darkness of interstellar space? 3i Atlas was glowing, not with the chaos of nature, but with the steady cadence of a machine or an organism. It was not just reflecting the light of our sun, it was sending its own light back into the void, as if it was expecting someone or something to notice. As the various observatories and deep space probes began to align their findings, a coherent and deeply unnerving image of 3i Atlas started to form. It was no longer seen as a passive rock drifting through the interstellar medium, but as a dynamic, reactive, and highly complex body. Each individual fragment of data, which had once been dismissed as an isolated curiosity or a statistical anomaly, now fit perfectly into a larger, unsettling pattern. The hyper-reflective jets that were observed during its perihelion pass were not random outgassing events. They were precisely aligned with the peaks in the solar flux, suggesting a controlled release of material. The object's non-gravitational acceleration, which had previously been explained away as the result of asymmetric outgassing, was now shown to follow a clear mathematical periodicity. It was responding not to the simple heat of the Sun, but to the complex gravitational gradients between the planetary alignments in our solar system. This suggested a responsive, control-like behaviour, not the simple chemical chaos of a melting comet. This was a level of sophistication that was completely unexpected and deeply puzzling. The organic compounds that had been detected, some of which showed a distinct chirality and biogenic-like carbon ratios, were found to be embedded within a protective matrix that shielded them from the destructive effects of radiation decay. Their remarkable stability over the long durations of interstellar travel hinted at a deliberate design, not a random accident of nature. When viewed in isolation, each of these facts was a strange anomaly. But when they were synthesized and viewed together, they painted a portrait of clear and undeniable intention. The rotational pulses of Atlas, its strange isotopic asymmetries, and its rhythmic spectral emissions all seemed to follow a set of internal harmonics. It was like a song that was meant to be heard across the vastness of space. The object seemed to be broadcasting not just raw data, but a complex and structured pattern. From its entry into the outer solar system to its closest approach to our planet, 3i Atlas displayed a behavioral chain, a sequence of actions that escalated in complexity and then, just as suddenly, receded. It appeared to activate, reveal itself, respond to its environment, and then, abruptly, it went silent again. Some analysts began to whisper comparisons to Oumuamua, the first interstellar object ever detected, which had also displayed anomalous acceleration. But others insisted that Atlas was no twin. This was something far more complex, something that felt more like an organism of design, or a device with a clear purpose. And now, standing at the intersection of chemistry, trajectory, and intention, the question was no longer whether Atlas was special. The question was whether we had just witnessed its message, and if we had missed it entirely. As the analytical teams began to cross-reference the vast amounts of data from the ultraviolet, radio, and mass spectrometry instruments, a quiet but persistent question began to form. It was a question that has haunted the field of exobiology for decades. Was this strange and enigmatic body simply reacting to the laws of physics in a highly unusual way, or had it been deliberately shaped, perhaps even engineered, to sustain life? 3i Atlas was clearly no ordinary interstellar object. Its surface bore the unmistakable signatures of selective shielding, with layers of carbonaceous material that were highly resistant to both ionizing radiation and the constant bombardment of micrometeorites. Deep beneath those protective outer layers, transient pockets of heat had been detected. These were zones where the internal temperatures surged and then stabilized on a periodic basis, completely defying the expected thermal decay of a simple cometary nucleus. These warm cavities hovered within a temperature range that has been theorized to be capable of supporting complex biochemical processes, particularly the kind of extremophilic microbial activity that thrives in the harshest environments on Earth. It was a tantalizing hint of a habitable niche within this alien object. But the anomalies of Atlas did not stop there. Inside the materials that were ejected from the object near its perihelion, researchers identified what appeared to be amino acid analogues that had a consistent L-chirality, a feature that is almost exclusively found in Earth-origin biochemistry. Even more puzzling were the traces of phosphorus-laden chains that exhibited a strange reactivity. They were active under the ultraviolet light of the sun, but they degraded rapidly when exposed to artificial light in the lab, as if they were specifically tuned to the conditions of a natural star. These chains bore a striking resemblance to primitive RNA scaffolds, yet they were stable far beyond any terrestrial models. Was this the undeniable footprint of life, or was it a sophisticated, engineered mimicry of its conditions? The theorists were divided. Some leaned toward the idea of panspermia, suggesting that Atlas might be a dormant vessel, a cosmic seed carrier, transporting the basic building blocks of life, but not life itself. Others pointed to its non-random activation sequence as evidence of something more. The thermal pulses that occurred just before its acceleration, the spectral emissions that were perfectly timed with planetary conjunctions, and its sudden shutdown precisely at observational blind spots. That complex choreography hinted at more than just survival. It hinted at awareness. 3i Atlas did not present life as we knew it, but it mirrored the fundamental logic of life: adaptation, protection, signaling, and a complex internal structure. It operated within environmental margins that had long been believed to be completely inhospitable, yet were suspiciously close to the known thresholds for extremophiles. As the world looked on, Atlas was forcing an uncomfortable and profound redefinition of our understanding of the universe. Perhaps the question was not whether there was life out there. Perhaps the question was whether life, in some strange and unrecognizable form, had just passed us by, measured, contained, and ultimately unrecognized. As the international astronomy community continued to review the cascade of data from 3i Atlas, the expert interpretations began to diverge, yet none of them could ignore the underlying undeniable pattern. The structure of the object was too precise, the timing of its actions was too refined, and its energy signatures were too deliberate to be dismissed as mere cometary coincidence. The spectroscopists on the team pointed to the rhythmic emissions as clear indicators of a programmed decay or a controlled energy release. Rather than following the random patterns of outgassing, the signals from Atlas maintained a steady, unwavering periodicity, enough to prompt serious discussions about autonomous or even self-regulating systems. Some drew parallels to pulsars, though no neutron star had ever moved this close to us, or this slowly. The thermal imaging specialists highlighted the remarkable ability of Atlas to retain and actively channel heat along certain axes, almost like conduits or vents in a machine. These heated regions did not align with the object's exposure to sunlight, but rather with its own internal rotational rhythm. It was as though Atlas had been sculpted to breathe, taking in the raw energy of the sun and then redistributing it in controlled, predictable waves. It was a display of thermal management that was far beyond anything expected from a natural object. The astrobiologists, meanwhile, saw patterns that were too familiar to be ignored. The careful layering of its carbonaceous shells, the presence of complex organic molecules, and the strange isotopic gradients all hinted at a process of deliberate preservation, and perhaps even an incubator function. While most of the scientists refrained from making any open declarations, their internal memos and private communications spoke of a cautious and profound astonishment. The word designed began to appear more than once in their classified reports. Among the few who were willing to speak publicly about the growing mystery, Professor Lena Chen of the Vienna Astrophysics Institute summarized the feeling best. "We are seeing consistency where we should be seeing chaos," she said. "This object behaves like a system, not a relic." The conversation was no longer just about what Atlas was. It was now about who or what might have once engineered or deployed it. And it was about whether Earth had just witnessed the ghost of a logic that was far older and far more advanced than its own. When 3i Atlas first entered the observable zone of our solar system, the orbital analysts had every expectation that it would follow a standard hyperbolic trajectory, consistent with all other known interstellar visitors. Yet, within just a few days of plotting its path, residuals began to accumulate in the data. They were subtle at first, but then they became undeniable. Atlas was not simply passing through our system. It was deviating slightly but persistently from every single gravitational prediction. The initial models, which had been carefully calibrated to account for barycentric coordinates and the subtle pressure of the solar wind, failed to hold. The object's motion introduced a drift vector that seemed completely non-random. It appeared to be actively resisting the solar perturbations rather than yielding to them. The calculations that were being run using the standard JPL Horizon solutions began to report increasing errors in its right ascension, errors that grew with time instead of shrinking as more refined data came in. It was as though Atlas had its own intentions, as if it was constantly correcting or rebalancing its course in response to some unknown frame of reference that was invisible to us. The anomaly only intensified as the object neared its perihelion. While most celestial bodies accelerate predictably as they fall toward the Sun, following the established laws of Keplerian mechanics, Atlas slowed down and then regained its speed at a moment that was completely inconsistent with any predicted solar maneuver. This strange phase shift, which was minor in terms of its delta-v but major in its implication, prompted the orbitalist to revisit the trajectory of Oumuamua for comparison. But the deflection of Atlas was not a single, one-time burst of acceleration. It was incremental, layered across time like a series of tiny, precise micro-thrusts. Some of the scientists suspected that sublimation or gas jets were responsible for the changes, but there was no tail behavior that corresponded to the vector changes. The jets, when they did appear, were orthogonal to the direction of motion, not reactive. The pressure from solar radiation could not explain the consistency of the maneuvers. The radiation modelling showed that there was no sufficient torque to cause the kind of rotational precession that would match the observed drift angle. The motion of this object was violating all known models for passive comets. That is when the term non-gravitational acceleration re-emerged in the scientific discourse, first cautiously and then pervasively. It had been used to describe the strange behaviour of Oumuamua, but here it was not just an epicycle of explanation. It became the defining variable of the entire encounter. Atlas appeared to be responding not just to the gravity of the Sun, but to something else entirely. Perhaps it was following an internal map, heading for a predetermined destination, or operating on a feedback loop that was invisible to our current instruments. As more data arrived, the errors in the predictive modelling reached a threshold where the new simulations had to assume a form of intelligent revectoring. It was not guidance in the human sense, but a series of deliberate course adjustments, like route corrections on a long journey. Some called it inertial buffering. Others hinted at a system of stored momentum. A few of the most experienced analysts simply admitted defeat. For the first time, trajectory was not just about gravity. It was about intent. 3i Atlas was not drifting. It was navigating. The object known as 3i Atlas did not drift into our solar system as a passive, inert object. From the very earliest reconstructions of its inbound trajectory, the analysts noticed something that was off-pattern. Instead of plunging through interstellar space with a chaotic random vector, Atlas had approached the heliosphere at a highly optimized slant. It was skimming the gravitational influence of the Sun in a way that maximized its acceleration while allowing it to remain within the ecliptic plane, the flat disk where all the planets of our solar system orbit. It was a controlled, efficient maneuver, not a cosmic coincidence. The data that was compiled from the James Webb Space Telescope, the ALMA array, and the mid-infrared sensors aboard the Sophia Observatory revealed a series of micro-adjustments in its velocity vector that had started well before it even crossed the Kuiper belt. These shifts were not random. They occurred at repeating intervals, subtle little nudges that seemed both deliberate and highly effective. What made them so extraordinary was the complete absence of any visible outgassing or the release of any reaction mass. There was a complete lack of any natural propulsive mechanisms, yet its trajectory changed, minutely but purposefully, suggesting a process of navigation rather than simple drift. When 3i Atlas approached the orbit of Jupiter, the simulations had predicted that it would experience significant gravitational interference, enough to alter its course drastically. But that never happened. Instead, Atlas bypassed the gas giant with what could only be described as surgical precision, like a spacecraft that was plotting a course to avoid a dangerous gravity trap. The maneuver completely defied the expectations of every standard celestial model. It was another clear sign that this object was not behaving according to the known rules of physics. Further down its trajectory, as Atlas passed into Earth's shadow cone, a region where our optical surveillance systems temporarily lose tracking due to the interference from the Sun, a new anomaly emerged from the radar network. A faint vector deviation was recorded. It was small, but it was directional. It was as if the object had made a conscious angular correction to slip past a specific satellite that was positioned in geostationary orbit. This was not evasion by luck. It was tactical. This behavior became a pattern, not frequent enough to raise immediate alarms, but consistent enough to rule out pure coincidence. Aerospace analysts began to draw parallels to the low reflectivity techniques that are used in electronic warfare, such as soft signal jamming, stealth bypasses, and maneuver masking. These are not the traits of a simple comet. They are tactics, and tactics require either intelligence or a set of complex instructions. 3i Atlas was not merely moving through space, it was responding to its environment. This gave rise to a controversial but unavoidable inference. Atlas might possess some level of agency, either on board or controlled remotely. It was not being guided by gravity alone. It was choosing its own path. It was not just avoiding obstacles, it was actively minimizing its exposure. It was not revealing itself in full, but showing just enough to be detected and questioned. The idea of intentionality began to shift the entire narrative of the encounter, from a simple scientific anomaly to a potential strategic presence. Was this object hiding from us, watching us, or perhaps even testing us? The scientific community hesitated to say it out loud, but the thought was now undeniable. If these flight corrections were indeed intentional, if its approach vector had been optimized from interstellar space, then 3i Atlas was not just visiting. It was approaching with a reason. The sum of all the anomalies surrounding 3i Atlas began to exceed what natural randomness could possibly explain. Each directional shift, each evasive maneuver, and each instance of timing precision, when taken alone, might suggest the work of chance. But, collectively, they formed a clear and unmistakable pattern of coordinated non-ballistic movement that was indicative of active trajectory management. Unlike other interstellar visitors, such as Oumuamua, which had coasted inertly through the gravitational wells of our solar system, Atlas demonstrated controlled approach dynamics, precise acceleration timing, and sophisticated avoidance behavior. Its flight path was not only highly efficient, it was also adaptive. It was constantly adjusting its course without any visible cause, always optimizing its position relative to the planetary fields and our own sensor lines of sight. A new hypothesis began to emerge, not from sensationalism, but from the repeated failure of all other models. What if 3i Atlas was not a passive body at all, but a directed object? What if it contained internal guidance systems, either autonomous or remote, or even operated with some form of intent? Its trajectory was not just unusual, it was structured. And structure in this context implied engineering. This possibility reframed the entire investigation. Atlas was no longer merely a scientific curiosity. It was now the center of a hypothesis that few dared to articulate fully, that something, or someone, might have sent it. The mystery deepened, not by what Atlas did, but by how consistently and precisely it did it. This was no accidental wanderer. It behaved like a scout. By the midpoint of the investigation, a fundamental shift had occurred in how 3i Atlas was being conceptualized. It was no longer seen as a singular anomaly, but as a branching narrative with multiple plausible realities. The object's trajectory, its composition, and its reactive behavior no longer aligned with any single known category of celestial phenomena. As analysts across all the participating agencies consolidated the mounting data, 3 major interpretative frameworks began to emerge. Each one was distinct in its implication, yet none of them could be fully dismissed. The first scenario classified 3i Atlas as an ultra-anomalous natural comet, one that defied all prior models due to a convergence of extremely rare but still natural astrophysical processes. According to this view, the non-gravitational acceleration could be explained by an exotic sublimation pattern, perhaps involving volatile compounds that had not yet been catalogued, or driven by exposure to high-energy solar emissions that triggered an asymmetric outgassing. This scenario required the fewest new assumptions, yet it demanded a belief in an almost statistically impossible combination of natural forces. Its supporters pointed to the object's irregular jet emissions, and proposed that internal reservoirs of hypervolatile materials shielded by crustal anomalies might account for the sudden directional thrusts that were observed after its perihelion. But even among the most conservative theorists, a deep discomfort lingered. Too many variables had to align perfectly. It was, in their own words, the least unlikely natural explanation. The second hypothesis treated Atlas as a derelict, a remnant of some ancient alien technology. It was not active, but it was not entirely inert either. In this framework, the structure was interpreted as a non-functional artifact of artificial origin. Perhaps it was a probe, a scout ship, or a segment of some greater interstellar construct that was no longer operational. The presence of modular symmetry, the geometric anomalies, and the spectral reflections that were inconsistent with mineralogical expectations all lent some support to this idea. Data suggesting internal cavities and a multi-layered shell architecture hinted at the possibility of internal compartments that were once functional but had now decayed. The jets could be the remnants of engineered propulsion systems degraded by time or exposure to the harshness of space. This theory also explained the highly coordinated orbit corrections as the result of residual programming or self-stabilizing systems that were still reacting to gravitational vectors. Unlike the first scenario, this hypothesis accepted that the anomaly was not due to nature's creativity, but to technology's entropy. In this telling, Atlas was a ghost. The third and most controversial scenario proposed that 3I Atlas was an active, functioning interstellar entity. It was either an autonomous or a remotely directed craft, operating with a real-time awareness of its trajectory and its environment. This view, which was initially dismissed by many in the scientific establishment, had gained significant traction, not through sensationalism, but through a simple process of elimination. The precise timing of Atlas's solar approach, the coherent coordination of its perihelion maneuvers, and its strategic alignment with the planetary orbital planes all resisted any naturalistic modelling. Its non-random dimming patterns, its spectral emissions that were outside the expected solar reflectivity range, and its strategic silence during critical observation windows all suggested control, not coincidence. If Atlas was alive, technologically or otherwise, it had chosen when and how to be seen. Its route, including the gap event when it passed behind the Sun, echoed the patterns seen in proposed orbital maneuvers like the Oberth effect techniques that have been theorized for interstellar propulsion. For the believers in this scenario, Atlas was not merely a traveler, it was a visitor. Each of these hypotheses carried its own emotional and scientific gravity. The first scenario preserved our sense of normalcy, but it stretched the bounds of probability to the breaking point. The second teased at an ancient history of cosmic exploration, one that we might have just stumbled into the ruins of, and the third confronted humanity with an unthinkable possibility, that we are not alone and that contact may already be in progress, not through beacons or messages, but through a quiet physical presence. Crucially, none of these scenarios could yet be proven or ruled out. Instead, they coexisted, like the overlapping layers of a puzzle that was not yet solved. The analysts began to refer to this phase of the investigation as the triple collapse point, where all the lines of reasoning converged but refused to simplify into a single answer. The tension did not lie in the lack of answers, but in the abundance of profound implications. Each theory rewrote the human narrative in its own way, and the final determination would depend not just on more data, but on how willing Earth's scientific community was to ask the questions it had long avoided. 3I Atlas had fractured our consensus, not because it was inexplicable, but because it was almost perfectly explicable through 3 different lenses, each whispering a different and world-altering truth. As the directed object hypothesis gained credibility among the various science teams, a new and urgent question began to surface. It was a question not of science, but of protocol. If 3I Atlas was truly an engineered entity, should humanity attempt to respond? In secure discussions that took place across observatories, defense agencies, and academic circles, this single issue fractured the communities that had been working so closely together. One camp argued strongly for transmission. They advocated for sending a directed signal, encoded with benign intent, a universal handshake across the cosmic void. The opportunity to initiate contact, they believed, was a singular and historic moment in the arc of our civilization. Silence, in their view, would be a betrayal of our fundamental curiosity. The opposing camp warned of catastrophic and unknown risks. If Atlas was observing, or worse, evaluating us, then sending a signal might reveal Earth's precise location, our technological status, or even our vulnerabilities. Historical analogies from Earth's own colonial past were invoked as a stark warning. Contact does not guarantee diplomacy. And then there were those who questioned whether Atlas was waiting to be answered at all. Perhaps it was simply passing through, an observer that was never meant to be intercepted. In this quiet, unresolved debate, the world was at a standstill. Across the global networks, a decision loomed, one that was not about capability, but about philosophy. Should we speak, or should we listen? And for now, humanity chose neither. It simply watched. As the anomalies surrounding 3I Atlas continued to accumulate, formal assessments began to emerge from the world's most authoritative agencies. The SETI Institute was the first to release a cautious briefing, emphasizing the critical need to distinguish between natural and artificial signal patterns. Their analysis confirmed that the electromagnetic profile of Atlas contained significant irregularities, including narrow band bursts and anomalous radio transients that merited further, intense observation, though they stopped short of attributing any intent to these signals. Meanwhile, the European Space Agency focused its analysis on the object's trajectory and structural data. Their orbital reconstructions showed a course that was deviating from classical Newtonian expectations, particularly during its perihelion, where the gravitational slingshot effects failed to account for the altered arc of Atlas. Internally, ESA analysts raised serious concerns about its energy sources. None were detectable, yet the directional changes persisted. The implication was clear: propulsion without emissions. NASA, which is typically measured and conservative in its tone, released a technical bulletin that acknowledged the non-standard behavior of 3I Atlas. Their deep space network had recorded fluctuations in the reflected light from the object that could not be linked to any natural outgassing or dust fragmentation. Most striking of all was the object's remarkable structural coherence. While comets and asteroids tend to exhibit irregular mass shedding, as they are stressed by gravity and solar radiation, Atlas remained visually intact, even under the extreme conditions of its close solar pass. Though none of the agencies were willing to officially declare that Atlas was artificial, their language had shifted dramatically, from denial to ambiguity, from anomaly to possibility. A silent convergence was forming in the global scientific community. Atlas defied all categorization. It no longer fit any of our known models, and that, perhaps, was the loudest signal of all. As 3I Atlas continued its mysterious trajectory through the inner solar system, a new phase of global surveillance was launched. It was no longer a passive subject of distant telescopes. Atlas had become the focus of an intensified, globally coordinated observation campaign. Agencies around the world recalibrated their most valuable assets. The James Webb Space Telescope, which had already provided the initial crucial data on its reflectivity and jet structures, was reassigned to conduct intermittent high-resolution captures of the object. Meanwhile, Earth-based facilities, including the ALMA array, the Arecibo surrogate systems, and the ESA's deep space antennas, were all aligned for synchronized sweeps of the sky. The early data that came in during this new phase yielded even more contradictions. The spectroscopic readings revealed sudden and dramatic alterations in the ultraviolet and infrared bands. A chemical signature that had first been assumed to be residual cyanogen began to fluctuate in a way that was completely inconsistent with the known decay patterns of cometary nuclei. Furthermore, the ion tail of Atlas, rather than trailing behind it in a predictable arc, began to drift at unphysical angles relative to the solar wind vectors. These observations did not merely challenge the pre-existing models, they invalidated them. More disturbing were the temporal anomalies that were being detected between observation windows that were spaced 14 hours apart. The visible jet orientation of Atlas had shifted by nearly 26 degrees, without any correlating positional torque. This raised urgent questions about the presence of internal control systems or active stabilization, concepts that were completely alien to the study of celestial debris. Some researchers postulated that rotational precession was the cause, but when the spin rate was recalculated, it was found to be far too stable. A critical transition in the investigation occurred when the enhanced network began to observe regular photonic pulses coming from the nucleus of Atlas. These were precise flashes of light, occurring in exact intervals of 247 seconds. They repeated over 3 full cycles before stopping abruptly. Their wavelength distribution suggested that there was no natural mechanism that could be producing them, leading the analysts to seriously consider the possibility of intentional emissions. Though they remained cautious in their public statements, the CT Consortium quietly logged the event as a non-random temporal anomaly. Emotionally, the scientific community stood divided, with a sense of excitement that was deeply shadowed by uncertainty. Some feared that they were making premature conclusions, others whispered that something had just blinked back at them. Whatever 3i Atlas was, it had now become something more than just an object to be observed. It had become an observer itself. Following the anomalous pulse emissions from 3i Atlas, the global scientific response entered its second operational phase, the theoretical construction of a standardized outbound message. Unlike previous contact efforts, which had been aimed at a generalized unknown extraterrestrial intelligence, such as the Arecibo message or the Voyager Golden Record, this effort was focused on formulating a signal that was precise, concise, and technically decipherable by an unknown entity that was already exhibiting structured emission behavior. The urgency of this phase was amplified by the results of statistical modeling. An AI-assisted pattern analysis had revealed an uncanny symmetry in the 247-second intervals of the pulses. They were too precise for stochastic fluctuation, too deliberate for mere cosmic coincidence. With that data in hand, the attention of the scientific community shifted from passive surveillance to a calculated response strategy. The fundamental question was no longer what is it, but can it understand us? A working group led by CT and supported by interdisciplinary teams from MIT, JPL, and the ESA began to reverse engineer signal templates that were optimized for universality. Binary encoded prime sequences were tested, as well as image compression algorithms that were encoded into hydrogen line frequency modulations. The core idea was to construct a message that was rooted in the natural laws of the universe: mathematics, atomic, structure, gravitational ratios that any sentient civilization would also observe. But with 3i Atlas showing unexpected photonic emissions and structural anomalies, the risk was clear. If they sent too much information, they could risk provocation. If they sent too little, they risked being ignored. This was no longer just astrophysics. This was first contact diplomacy, conducted at an interstellar distance with no guaranteed feedback loop. Psycholinguists joined the effort, proposing patterns of semantic symmetry that might indicate self-awareness in any return signals. Meanwhile, the engineers debated the timing. Should the message be sent during Atlas's solar transit, when its shielding might be compromised, or should it be sent in the weeks before its closest approach to Earth? Behind the scenes, classified briefings began to emerge from military space agencies, requesting veto rights over any outgoing transmission. Their concern was not scientific, it was strategic. If 3i Atlas was a probe, then any reply was an act of disclosure. And so, the second phase ended not with a consensus, but with a prototype. It was a message encoded in hydrogen spin resonance patterns, structured in Fibonacci timing loops, and approved for silent activation. Pending any further signals from Atlas itself, the world waited. 3i Atlas remained silent, but its silence no longer felt passive. While the scientists debated frequency modulations and diplomatic payloads, a different kind of urgency was unfolding below Earth's ionosphere, among its people. The third phase of the global response to 3i Atlas revolved not around data, but around perception. It was no longer about what humanity knew, but about how it felt. The moment that word of Atlas's anomalous behavior reached the mainstream media, its coordinated jet structures, its photonic symmetry, the mysterious signal pulses, the narrative broke containment. Social networks fractured into polarized streams of wonder, fear, and denial. Some believed that it was the long-awaited first contact. Others feared a hidden threat. A fringe minority insisted that the object was a classified, Earth-made technology. The truth, stripped of consensus, had become radioactive. Government communication channels struggled to maintain coherence. NASA's public statements remained cautiously neutral, referring to Atlas only as an interstellar body of interest. The ESA released technical updates but withheld any commentary on the biological implications of the molecular data. SETI, for its part, began a series of live streams that were designed to educate, not to inflame. Yet the silence from the major geopolitical actors, Russia, China, and several military agencies, only deepened the atmosphere of distrust. Psychological impact models developed in partnership with the WHO and international behavioral labs predicted a range of possible outcomes. Mild public anxiety was expected, but by the second week of sustained media coverage of Atlas, real disruptions began to emerge. The markets showed significant volatility, conspiracy narratives surged, religious leaders called for prayer or warned of a great deception. In cities from Seoul to São Paulo, citizens gathered not in protest, but in vigil. A particular complication emerged, a phenomenon known as ontological shock. This is the destabilizing psychological effect of confronting evidence that directly contradicts one's worldview. For some, it was liberating. For others, it was paralyzing. And for many, it triggered a quiet, existential recalibration. If 3i Atlas was indeed intelligent, or even just designed, then humanity's place in the universe had already shifted. Crisis communication experts began recommending soft disclosure tactics, using analogies to past scientific revolutions and framing the event as an opportunity for unity, not for dread. Yet these efforts met with resistance. The truth, however softened, refused to be domesticated. The phase closed with a paradox. Humanity had never been more connected, yet it had never been more uncertain. The skies were watched, the feeds were refreshed hourly, and through the static of a million screens, 3i Atlas continued its silent passage, seen but undecided. The skies were watched, the feeds were refreshed hourly, and through the static of a million screens, 3i Atlas continued its silent passage, seen but undecided. But this global vigil was not a unified one. Behind the carefully worded press releases and the shared data streams of the scientific consortium, a shadow conflict was taking shape. The silence from Moscow and Beijing was not one of inaction, but of intense clandestine activity. While the Western-led coalition debated the ethics of contact, other powers were pursuing a more direct and unilateral approach. Their deep space tracking networks, operating independently, were not just observing Atlas, they were probing it. Covert radar pulses, far too weak to be considered an overt transmission, but strong enough to gather high-resolution topographical data, were directed at the object from undisclosed locations. These were attempts to map its surface in greater detail, to find weaknesses in its structure, or perhaps to trigger a response that could be analysed for technological signatures. This electronic prodding was a dangerous game. If Atlas was a passive derelict, it was a form of cosmic archaeology. But if it was an active, aware entity, it was a provocation. The risk of being perceived as hostile was immense, yet the strategic advantage of gaining unique intelligence was deemed worth it. The race to understand Atlas was no longer purely scientific. It had become a geopolitical imperative. Within the intelligence communities, a new kind of arms race was beginning. It was not for weapons, but for interpretation. Analysts who had spent their careers modelling missile trajectories and satellite capabilities were now tasked with deciphering the intent of an object that obeyed none of the known rules of engagement. Was its trajectory a path of observation, a prelude to communication, or an approach vector for something else entirely? Every micro-adjustment it made was scrutinised, every thermal pulse analysed for patterns that might betray its purpose. The three dominant hypotheses, comet, derelict, or visitor, became strategic frameworks. Depending on which you believed, Atlas was either a scientific prize, a technological treasure trove, or an existential threat. And each nation was placing its bets. This fragmentation extended to the scientific community itself. The initial spirit of global cooperation began to fray at the edges. Data packets from certain observatories would arrive with slight delays or corrupted checksums, small anomalies that suggested information was being filtered or held back. Scientists who had once collaborated freely on papers and projects now spoke in coded language during video conferences, aware that their conversations were likely being monitored by more than just their peers. The triple collapse point was not just an intellectual problem, it was a political one. The hypothesis you endorsed could align you with a specific national interest, and the pressure to conform to an official narrative whether one of scientific caution or strategic alarm, was growing. The quest for knowledge was becoming entangled in the old, familiar webs of power and suspicion. Humanity was looking at the stars, but it was still seeing its own reflection. Meanwhile, the ontological shock continued to ripple through the fabric of society, transforming from a media phenomenon into a deeply personal and cultural force. It was not a sudden cataclysm of belief, but a slow, creeping tide of uncertainty that eroded the bedrock of long-held assumptions. Art and music began to reflect this new reality. Canvases that once depicted earthly landscapes were now filled with hexagonal patterns and the cold, bioluminescent glow of an alien object. Composers wrote symphonies not of human triumph, but of cosmic solitude, using the 247-second pulse of Atlas as a recurring, haunting motif. A new genre of literature emerged, dubbed contact realism, which explored the quiet, mundane anxieties of living in a world where humanity's uniqueness was no longer a given. Philosophers and theologians found themselves at the centre of a renewed and urgent public discourse. For centuries, the question, "Are we alone?" had been a theoretical exercise. Now it was a practical matter with profound implications. If Atlas was a natural object of impossible complexity, it suggested that the universe was far more creative and strange than previously imagined. If it was a derelict artifact, it meant that other civilizations had risen, and perhaps fallen, leaving humanity to ponder its own longevity. And if it was an active visitor, then every religious text, every philosophical system, every definition of what it meant to be human had to be re-examined. Public debates, broadcast to billions, featured scientists, spiritual leaders, and ethicists grappling with questions that had no easy answers. What is the nature of consciousness? Does intelligence require a biological form? What moral obligations do we have to a non-human entity? This existential questioning manifested in countless ways. In some places, it led to a renaissance of scientific curiosity, with university enrollments in physics and astrobiology skyrocketing. People who had never looked up at the night sky were buying telescopes, joining amateur astronomy clubs, and learning to trace the path of Atlas as it moved slowly against the familiar constellations. It became a shared global ritual, a silent communion with the unknown. In other corners of society, however, the shock curdled into fear and paranoia. New cults formed, centered around the worship or dread of the sky visitor. Conspiracy theories became more elaborate, weaving Atlas into existing narratives of secret governments and hidden agendas. The psychological strain was palpable. Mental health hotlines reported a surge in calls from people experiencing what therapists began to call cosmic anxiety, a profound sense of insignificance and disorientation. The global economy also began to adapt to this new paradigm. A space bubble formed in the markets, with investors pouring money into aerospace technologies, artificial intelligence, and any company that seemed poised to play a role in the next chapter of human history. At the same time, industries rooted in certainty and predictability began to suffer. The very idea of a long-term forecast seemed absurd in a world where the fundamental context of human existence could change overnight. Humanity had become a species in waiting, holding its collective breath. The silent passage of Three-Eye Atlas had done more than just challenge our science. It had held up a mirror, forcing us to confront our own beliefs, our fears, and our profound, shared vulnerability in the face of a truly vast and mysterious cosmos. Then, on the 97th day of the observation campaign, Atlas acted. It did not send a message in radio waves or light pulses. It did not reveal a hidden structure or emit a new chemical signature. It did something far more direct and far more terrifying. It changed course. This was not the subtle, non-gravitational drift that had puzzled scientists for months. This was a clear, sustained, and unambiguous maneuver. Over a period of 17 hours, Three-Eye Atlas executed a controlled burn, though still with no visible propulsion, that altered its trajectory from a wide, sweeping orbit around the Sun to a direct approach vector. Its new destination was not Earth itself, but a gravitationally stable point in space known as the Earth-Moon Lagrange Point 1, or L1. L1 is a unique location, a place where the gravitational pull of the Earth and the Moon cancel each other out, allowing an object to remain in a fixed position relative to both bodies. It is the perfect observation post, a cosmic high ground from which to survey the entire Earth-Moon system. For Atlas to move, there was not an act of chance. It was a statement. It was the equivalent of a ship dropping anchor just outside a harbour. The manoeuvre was executed with a precision that stunned the orbital analysts. It was a low-energy transfer, perfectly optimised to conserve momentum, a textbook example of advanced orbital mechanics. The calculations required to plot and execute such a course were complex, requiring a deep and accurate understanding of the solar system's gravitational landscape. Atlas, it seemed, had done its homework. The global scientific consortium, which had been fractured by suspicion, was instantly reunified by a shared sense of awe and dread. There was no longer any room for debate. The ultra-anomalous natural comet hypothesis evaporated in an instant. No natural process could account for this. The derelict artifact theory also seemed increasingly unlikely. A ghost in the machine might account for residual course corrections, but not for a sustained, powered, and perfectly targeted orbital insertion. The third hypothesis, that Atlas was an active, functioning, and intelligent entity, was now the only one that fit the facts. The triple collapse point had collapsed into a single, terrifying reality. The news of the trajectory change could not be contained. Within an hour it was the only story on the planet. The ontological shock that had been a slow, creeping tide now became a tidal wave. Panic, which had been simmering beneath the surface of society, began to boil over. Stock markets around the world suspended trading to prevent a total collapse. Governments declared states of emergency, not because of any immediate physical threat, but to manage the overwhelming public reaction. The vigils of wonder turned into gatherings of fear. The question was no longer, what is it? But, what does it want? 3i Atlas, by moving to the L1 point, had made a choice. It had ceased to be a passive observer and had become an active participant in our corner of the cosmos. It had placed itself in our immediate vicinity, a silent, 800-metre-wide enigma hanging in the void between the Earth and the Moon. It was now close enough that large ground-based telescopes could resolve its hexagonal surface with breathtaking clarity. It was no longer a faint point of light or a fuzzy image on a screen. It was a place, and from that place it watched. Humanity's period of quiet, uncertain waiting was over. The time for a decision had arrived. The manoeuvre of 3i Atlas into a stable orbit at the L1 Lagrange point acted as a global catalyst, forcing an immediate and final confrontation with the question that had been haunting humanity for months: to transmit or not to transmit. The debate was no longer a theoretical exercise for scientists and philosophers. It was now the most urgent strategic decision facing every world leader. The prototype message, once a cautious contingency plan, was now on the table as a real and imminent possibility. Within hours of the orbital insertion, an emergency session of the United Nations Security Council was convened, a meeting that brought together not just diplomats, but the chief scientist of the Atlas Consortium and the highest-ranking military strategists from every major power. The chamber, usually a theatre of geopolitical posturing, was heavy with a silence born of shared uncertainty. The pro-transmission camp, led by the SETI Institute and a coalition of scientific bodies, made their case with renewed urgency. They argued that Atlas's move to L1 was not an act of aggression, but an invitation. It had placed itself in a neutral, observable position, a clear and deliberate gesture that seemed to demand a response. To remain silent now, they contended, would be interpreted as hostility, fear, or indifference. The message they had prepared, a simple, elegant packet of information based on fundamental constants, like the hydrogen line and the value of pi, was designed to be a peaceful greeting, a declaration that the inhabitants of the third planet were rational, aware, and ready to communicate. It was, they argued, humanity's best and perhaps only chance to shape the narrative of this encounter. The anti-transmission camp, now dominated by military and security advisors, presented a starkly different interpretation. They viewed the L1 maneuver as a tactical move, the seizure of a strategic position. An object with the demonstrated ability to manipulate its trajectory without visible propulsion possessed a technology so far beyond our own that any interaction had to be approached with extreme caution. Transmitting a signal, they warned, would be like revealing the location of your command center to an unknown army. It would confirm not just our intelligence, but our technological level, our planetary defenses, and our precise location. They argued for a strategy of active silence, intensifying observation and preparing defensive contingencies, but making no move that could betray weakness or be misinterpreted as a threat. Their core argument was simple and powerful. In a first contact scenario, the civilization that speaks first loses its greatest strategic advantage, the element of surprise. The debate raged for 18 straight hours, broadcast live to a world that was hanging on every word. The old divisions of nation and ideology seemed to fade, replaced by a more fundamental split in human psychology, between hope and fear, curiosity and caution. As the argument circled, a third option began to emerge, a compromise born of the deep, paralyzing uncertainty of the moment. It was proposed not by a scientist or a general, but by a philosopher who had been invited to advise the council. Her proposal was simple. Before sending a message of our own, we should first demonstrate that we had understood its message. She argued that the actions of Atlas, its trajectory, its thermal pulses, its rhythmic glow, were not random. They were a form of communication in themselves, a message written in the language of physics. Its move to L1 was its most articulate statement yet. Perhaps, she suggested, our first response should not be to broadcast our own identity, but to acknowledge its presence with a reciprocal, non-verbal gesture. We could, for example, use a network of powerful lasers to project a simple geometric pattern onto the dark side of the Moon, a pattern that mirrored the hexagonal structures on Atlas's own surface. It would be a signal that required no translation, a quiet acknowledgement that said simply, "We see you, we recognize your pattern, we are here." This idea, elegant and cautious, quickly gained support. It was a middle path that satisfied both the desire to act and the need for prudence. It was not a conversation, but the prelude to one. It was a way to respond without revealing too much, a gesture of intelligence without the risk of aggression. The council voted, and the decision was nearly unanimous. Humanity would not speak. Not yet. It would reflect. As the world's most powerful laser arrays were being calibrated and aimed at the lunar surface, a profound quiet settled over the planet. The noise of panic and debate subsided, replaced by a shared sense of anticipation. For the first time since the ordeal began, humanity was not fragmented. It was united in a single, collective act of watching and waiting. On screens around the globe, two images were displayed side by side. The cold, alien form of Three-Eye Atlas hanging in the blackness of space, and the pale, familiar face of the Moon, waiting to become a canvas for humanity's first reply. The final paradox remained. In the face of the ultimate unknown, humanity had chosen to answer not with its voice, but with a reflection of the mystery itself, hoping that in the shared language of symmetry, a bridge to understanding could be built across the silent void. Undefined. The skies were watched, the feeds were refreshed hourly, and through the static of a million screens, Three-Eye Atlas continued its silent passage, seen but undecided. In the face of the ultimate unknown, humanity had chosen to answer not with its voice, but with a reflection of the mystery itself, hoping that in the shared language of symmetry, a bridge to understanding could be built across the silent void. The operation was codenamed Echo. It was an act of engineering and diplomacy on a scale never before attempted. A network of 22 high-powered laser facilities across the globe, from the clear, high deserts of Chile to the frozen plains of Siberia and the heavily fortified research centers in the American Southwest, were synchronized to a single atomic clock. Their task was to project a coherent, stable image of a perfect hexagon onto the unlit portion of the Moon's surface visible from the L1 point, a canvas of dark regolith nearly 240,000 miles away. It was a message written in photons, a gesture of pure geometry. A hush fell over the planet as the countdown reached its final seconds. In public squares, on city rooftops, and in quiet living rooms, billions of people watched the live feeds. There was no cheering, no celebration. The moment was too heavy for that. It was a collective act of hope, tinged with a profound and primal fear. Then, at the appointed time, the lasers fired. They were invisible to the naked eye, thin beams of focused energy slicing through Earth's atmosphere. For 3 tense minutes, nothing seemed to happen. Then, on the screens fed by telescopes locked onto the Moon, a faint ghostly shape began to resolve. 6 perfectly straight lines of pale white light etched themselves onto the lunar dust, forming the familiar six-sided shape that now defined humanity's greatest mystery. The echo was live, the pattern held, a steady, unwavering symbol against the darkness. In the control rooms of the Atlas Consortium, every instrument was focused on the object at L1. Scientists watched its thermal signature, scanned for radio emissions, and monitored its faint bioluminescent glow for any change, any flicker that might betray a reaction. For the first 7 minutes, there was nothing. Atlas remained perfectly still, its rhythmic glow pulsing at the same steady 247-second interval. A quiet sense of anticlimax, of disappointment, began to creep into the room. Perhaps the gesture was too subtle. Perhaps it was meaningless to an intelligence that did not perceive light or geometry as we did. But then it happened. It was not a sudden movement or a loud transmission. It was a change in its light. The soft, rhythmic bioluminescence that pulsed from its cold side began to falter. The 247-second beat stuttered, paused, and then resumed at a new, faster cadence. The colour of the glow shifted, moving from a pale cyan to a deeper, more intense indigo. The change was subtle but unmistakable. Atlas was processing the information. It was responding. What happened next sent a shockwave of pure astonishment through every observer on Earth. The hexagonal patterns on the surface of Atlas itself, the physical structures first imaged by the JWST, began to glow. One by one, they lit up with the same deep indigo light, tracing a network across its dark hull. It was mirroring the pattern humanity had projected onto the moon. The message had been received. It had been understood, but Atlas did not stop there. After mirroring the hexagon perfectly for a full minute, a new light appeared. A single, brilliant point of white light ignited in the exact centre of each glowing hexagon on its surface. The original pattern had been acknowledged, and then amended. It was a response that was both a confirmation and a new, more complex puzzle. It had taken humanity's simple shape and added a new element. A nucleus. The lasers on Earth shut down, their task complete. The ghostly hexagon faded from the moon's surface, leaving only the silent, cratered landscape behind. But in the sky, at the L1 point, Atlas continued to glow with its new, altered pattern. It held the image for hours, a steady, shining beacon in the void. It had not spoken a word, but it had answered. The dialogue had begun. Humanity had offered a simple shape, a symbol of recognition. In return, Atlas had given back that shape, but with something new at its heart. It was a statement that seemed to carry 1,000 possible meanings. Was it a correction, a signature, a diagram of an atom, or was it a map, showing a star within a system, a destination within a structure? The relief of making contact was immediately replaced by the immense crushing weight of a new and far more difficult question. What was it trying to say? The silence was broken, but the mystery had only deepened.